Hello, fellow mathematicians. It seems that we've nearly got to the end of what you need to understand for Year 9 mathematics in Stage 5. So today, by the end of this lesson, you should be able to identify right-angled triangles in 3D solids and use Pythagoras' theorem, so you'll see Pythagoras' theorem, to solve some problems. So it'll usually be distances, because remember, with trig we can find angles and things like that. So I've got down here success criteria. We might be able to extend our understanding to use trig if we needed to, like find angles and stuff. So the first thing that you need to be able to do is you need to be able to identify or find a right angle triangle. Because if it doesn't have a right angle triangle, then we can't use Pythagoras. So here you can see it's already done for you. So this one has one. Here you can clearly see that that's a right angle triangle. Here this isn't a right angle triangle, but what we could do is we could cut it like that. Now this is a cube, so we know the corner in here is a right angle triangle. Again, it's still a cube, so even though the triangle is looking like it's turned or whatever, we can say that that one is a right angle triangle. Now if this went to a corner in a rectangular prism, we could say it is, but we can't for where it is on this diagram, this rectangular prism. We can't say or can't make that a right angle, so that one's a no. With here, with a triangular prism, we can say yes, that is. See how there's a right angle in that corner? Then there's going to be a right angle in that corner. This tetrahedron, we can't, because if I draw the triangle, it would go like that. And if this was an equilateral one, they'd all be equal. However, with a pyramid, we've done pyramids in our assignments and things like that, you will see that if there's a right angle triangle, if it goes from the center or the top of our pyramid to the center of the base. So that's why it's got the center of the base, and it's an apex is what they call that. So the first thing you need to be able to do is identify the 3D shape. Shouldn't be a problem. You guys are quite clever. The next thing you need to do is remember Pythagoras' theorem. And I know for some of you, remembering our formulas can be quite difficult. So this is why I ask you to write it every single time. So I'm going to write it for you. A squared, remember that's any arm. B squared is the other arm, and C squared is always the hypotenuse. So A and B are arms, and C is always the hypotenuse, which hopefully you remember is the longest side. So from the textbook, example 5 is what we'll be working through. Find the distance from one corner of the rectangular prism to the opposite corner. It has all this other information, but basically you need to be able to draw a diagram, because now we're going to go through the steps that we use all the time. First thing I actually do is draw and label a diagram. So they've given us a diagram. I don't want to draw on that. I want a nice clean triangle that I can work with. Going to label the size. So this is 3.9 meters and this is 8.3. By just drawing a new one, I don't get complicated, or I don't get mixed up with what else is in our diagram, in this diagram I'm talking about. So this might be too complicated for me. This is this one here is a nice, sweet and easy one for us to understand. The next step, label. By label I mean, here's the rule. So how can I label my diagram? I'm going to make this A. It doesn't matter which one. I'm going to make this arm B, and C is always the hypotenuse. So in this case, I might just put an X there, because X means I don't know what it is. So this is going to be my unknown side. My next step is to write the rule. So now I'm going to write the rule. Don't even have to think about it. A squared plus B squared equals C squared. The next step is to sub the values. Sub means just swap them out. So again, don't think about it. Don't skip this step. This is what our examiners look for. We look for, see how I've just, instead of writing A, I write 3.9. Instead of writing B, I write 8.3. And then I still put the squared there because these have to be there. And C, instead of writing C, I write x squared. Now what you do, now you grab the calculator. So I'll put 3.9 squared, that's that button there, plus 8.3 squared equals x squared. I just wrote it over here. X squared equals 84.1. So that's what x squared is. So to get rid of that squared, to get rid of this squared, you must square root both sides. So that gets rid of that. Basically it becomes that. Put that in your calculator. You have to press answer, not equals. That's the exact form. Press the button and it's 9.1706. So it's a really good habit to write down. Notice I've just gone ... because it keeps going. It's a good habit to get into, to write what your calculator says and then round it. So I think it wants 2 decimal places, so we'll do 2 decimal places. Remember the strategy I do. These are the 2 things I'm interested in. Look at the next number. If it's 4 and below, I ignore. If it's 5 and above, I add 1 to the previous thing. So this is 0, so I'm ignoring that, and it becomes about. Please make sure you do that. It's a really good habit. And what's the units? Meters. So I've got here, don't forget the units. I hope this will set you up for success.